Alright, so welcome back. We keep trying to solve an Oxford Mathematics admission test as per 30 of October 2019, and we keep starting type E. Alright, so trigonometry. And actually, for those who missed out all the previous videos, all previous problems that we discovered, just go back and have the reference. So actually, the full version of PDF document you can download. So in the link below, right, in the description. So feel free to do that and try first to go by your own. But for those who actually attempted and probably not succeed not in full, just let's get started. All right, so we've got the following. So we have actually the graph, but y from x is set up not like normal separate expression for y and for x, but sort of in a combination, and this combination is trigonometric. All right, so we got sine y minus sine x equals cos squared x and minus cos squared y. So actually the main question is about what sort of graph it might be here. Whether it empty, like not empty but includes no straight lines, means with no straight lines. And so there are the choices. Actually assume that it will include precisely one straight line, two straight lines, and many in terms of several or maybe infinite numbers. Okay, so how to solve that? Actually, if you're pretty well with trigonometric identities and equations that actually again IB syllabus or A-level stuff, so you can easily simplify that in order to have probably another form of presentation. So what I'm saying about, I'm just going to tell you that, guys, you simply can use the difference or sum of trigonometric functions with different angles. So I'm saying about this sort of rule. For example, we can use the difference of sinus of two different angles. So angles, let's say y and angle x. So according to the formula, we should get double product of cos semi-sum, right? X plus y over 2 and sine of the difference over 2. That's what exactly we'll have. Okay, that's first. I just work by parts. So first I work with that one, and then I just work with the right side. So that's the left hand side of the equations highlighted. Okay, so next step, let's work with that one. So number 2. So let's work with cos squared x minus cos squared y. Of course, there is no formula about cos squared x and cos squared y, but actually if you remember general formula about a difference of two squares, you'll get the following form as the factor. So basically our goal, so our goal is just to try to work with different parts and see what if we be able to factorize, because the main idea of how to solve equations is to factorize, right? Because in this case, anyway, you need to find out what sort of function finally you'll have in order to judge about is it empty graph or it will include some straight lines. Okay, so first of all, our idea is to get y from x. Okay, let's do it. So cos squared x minus cos squared y will write as the sum and as product as the sum and product of by the difference cos x minus cos y. All right, so here what we can do, we can apply two separate formula for sum of cos and the difference of cos, similar to what we apply to sinus. All right, so cos x plus cos y. Finally, if we apply the formula, we'll get cos of semi-sum and multiply by cos of the difference over 2. Okay, so what about cos x minus cos y? So we'll get minus 2 sine x plus y over 2 and sine x minus y over 2. Okay, but you know, everywhere we have, I just highlight that, we have the fact that it's y minus x, so I think it's better to rewrite this in order to have not x minus y, but y minus x. So you can use the property for sine, like sine minus alpha is minus sine of alpha. So you can swap difference here and put a plus sign, or just you can rewrite as minus this expression as minus cos y minus cos x, and in this case you'll have a proper difference. So let's see, indeed you'll have minus of, I just read that for a while, so we'll have minus and minus, so we'll get positive 2 sine of x plus y. Instead of x minus y, you'll get y minus x. Yeah, it's better to write like this. Okay, now it's good. It's positive. It's like more benefits. So what we can do, we can plug, instead of right side, the product of the sum of costs in the difference. Okay, we just plug in the right side of each equation. So also we will use for this difference of sign the fact that we write here, so put a black arrow, so we plug this whole expression instead of difference of sign. So basically all yellows plug in their place where it's supposed to be. Okay, so I first start from the left hand side and just rewrite this equation as the following. So difference of sign will be 2 cos x plus y over 2 sine y minus x over 2, and then we just have the product of this part and this part. So what we can get, so we'll have the following. So 2 times 2 is 4, so we'll get, okay, so 4 cos x plus y over 2 cos y minus x over 2, and we also need to include this factor. So 2 we already include, we'll get 4, so we're still multiplying by sine x plus y over 2 and sine y minus x. So sine y minus x over 2. Just one more time, compare and see what actually we did. So we'll put yellow parts into corresponding place. So right now we just need to transfer, I would transfer the right side, here, just to the left, so I put minus and equate to 0. And that's cool because we have 0 in the right side, so we can factorize and hence split y and x. So our goal was to split y and so x, right? So what we can do, we can factorize. So 2, we can factorize cos x plus y over 2. So I grab it from there. And also, well, we can also factorize sine, right? Sine of difference. So we'll get sine also y minus x over t. And finally, what we have, the following. So here we'll get just 1 minus 2, and here we'll have the left part cos y minus x over 2 and sine of the sum x plus y over 2. Alright, so the first possible solution when each factor, like this external factor, cos and sine be 0, right? And obviously this also might be 0. But it's enough because we need to just to complete the statements. It's pretty enough to do the following. So we can try to solve, for example, the first one, cos x plus y over 2. Can we? Yeah, we can do. So actually, we'll get the following. So cos x plus y over 2 is equal to 0, right? And in this case, if we start trying to solve, just remember unit circle. So what we're actually doing, so cos x plus y is 0, so it's pi over 2 in radians and minus pi over 2. But because we're looking for a general solution, obviously that will be infinitely big amount of solutions, because to each one we can add 2 pi n. So finally, we'll get the following. So x plus y over 2 equals to plus or minus pi over 2 plus 2 pi n. Okay, so here we can see that n is from z, and y as a function of x, and this is the key idea and basically the main outcome, is simply plus minus pi plus 4 pi n and simply minus x. So what sort of equation we have? We just have linear equation, right? So that's why y from x in the gradient intercept form, you just simply mx plus c. So we have a straight line. How many straight lines we have? Infinite many straight lines. So straight lines equation. So that's why obviously statement infinitely many straight lines, statement E is the only correct. Okay, so hope you enjoyed. Yeah, that was a little tough about remembering this formula, because actually even me sometimes forget what exactly like some difference, but you might have formula booklets and just try to memorize if you're not allowed in Oxford examinations. Okay, or try to maybe think analytically about how many possible solutions if you like connect x and y. So probably if you guess that it can be written in this manner, and you just have a look at each term, and probably you just bear in mind to factorize. So obviously x plus y over 2, the arguments or the difference definitely will be equal to some constant, right, with the n. So n number of circles basically you do in order to get, final answer. And that means there are lots of straight lines, okay? There are many straight lines. So you can do it analytically and save your time, but just I gave you a bit more detailed explanation applying just math science. All right, so hope you enjoy, guys. Don't forget to subscribe to be in touch with me, to be in touch with latest updates and the latest videos I create. So Daniel Dallas was there, and I hope I gave you all my best and clear explanation. See you.